two solutions. All right. If you need to write it down, write it down. If you think you got it, don't worry about writing it. That's up to you. These are your notes. But we need to remember what absolute value is. Just like Jenna said, it's the distance that a number is away from 0 on the number line. And since absolute value is talking about the distance of something, distance can never be negative, so that's why it's always going to be positive. Okay? So absolute value, the distance that a number is away from 0 on the number line. So the steps that we're going to use to solve these, you guys have already learned before. Now we're just going to step up our game, write our answers in either set notation or interval notation. Okay? Is everybody good? All right, so here we go. We're going to graph the absolute value of x equals 4 on a number line. And then we're going to determine what the solution set is. So we're kind of thinking about this backwards. So up there I had the absolute value of x equals 3. Here we have the absolute value of x equals 4. So I'm going to start at 0. And I'm going to go 4 units away to the right. And then I'm also going to go 4 units away to the left. Now let's think about the solution set. Is the solution set to this problem from -4 to +4? What would be the solution set? Would it be an interval or would it just be numbers? Don't write this because this is wrong. If I would say my solution is -4 to 4, someone give me a number in between -4 and 4. 0. Is the absolute value of 0 4? No. So it's not an interval of numbers. It's just a set of numbers. Well, which numbers would be in the set? For when I take the absolute value of them, they end up being 4. -4 and 4. It's just those numbers. So on a graph, they're just dots on the graph. And then set notation, -4, comma, 4. So the difference between a parenthesis and a bracket, or a brace, not a bracket, a brace. Bracket is our square-shaped thing. Set notation is listing it as a set. Remember yesterday we said let A equal, then we put the braces and 1, 2, 3, 4, 5, 6, 7, 8. So we just make a list of numbers inside the braces. Jenna, question?
So it's like with the absolute value of x equaling something, like if it were to be like 29, would it be -29 and full like 29?
Yes.
Okay.
Yep. Okay. Good question. So it doesn't matter what that number is. It's going to be both the negative and the positive of it. Okay. But do we all understand the difference between a set notation compared to our interval notation? Interval, if I were to put parentheses around this, that means I'm going from not including -4 to +4. If I put brackets around this, then I'm including -4 and then going to +4, including 4. Braces just means we're listing out the numbers in the set. Okay? Yes? All right. So now let's step up our game a little bit and turn it into an inequality. The absolute value of x needs to be greater than 4. What would that look like on a number line? So there's 0. So I need my distance from 0, pretty much is what this is telling me. I need my distance from 0 to be greater than 4. Well, what numbers are away from 0 that are greater than 4? Justin?
Actually, infinity.
Right. Is 4.1? Yes. Is 4? No, because it doesn't have that equal sign. So are we going to put a parenthesis or a bracket at 4? Parenthesis. Good. So let's go ahead and put 4 out there. Now we're going to put a parenthesis, and everything beyond that is a solution. But remember, negative 4 was also 4 units away from 0. So now I'm going to go over to negative 4. I'm not going to include it, but everything in that direction is also going to be more than 4 units away, right? Is everybody with me so far? So what would that look like as a solution set? We wouldn't use set notation. We're going to use interval notation because we're talking inequalities. It's an intersection or a union. A union, so we need to have a little u in between. What's this looking like in interval notation? Good. Negative infinity to negative 4, parenthesis, union, parenthesis, 4 to positive infinity. Okay. Okay, let's think about if it was less than. Are they okay? All right, so if the absolute value of x is less than 4, so that means I need the distance from 0 to be less than 4. Where would those numbers be? Would they be outside of 4 and negative 4 or in between? It's going to be in between. So is that going to be an intersection or a union? Yeah, that's going to be an intersection. So that's my solution area. How do I write that in interval notation?
Negative 4, 4.
Yes, negative 4, 4 with parentheses on both. Okay, so we get kind of the idea of absolute value. If it's absolute value and it's an equal, then it's just the numbers. If it's inequalities, then you need to think, well, is it going to be an intersection or is it going to be a union? Okay. All right, so now let's make the problems actually harder. Instead of just having x, let's add some fanciness to it. So we have the absolute value of 2x plus 1 equals 7. So are we going to have an interval as my solution or just numbers? Just numbers because of the equal sign, right? Is my absolute value on the left all by itself? Is there anything in front of it here? Is there anything behind it here? No. So since my absolute value is already by itself, I'm going to think, well, I need the distance that this whole thing is from 0 needs to be 7. So what are going to be the two numbers that I would have graphed on the number line? I would have graphed 7 and negative 7. If this would have been, don't write this, if this would have just been x equals 7, we would have said x equals 7 and x equals negative 7, right? And just put it in set notation. Well, now it's not just x. Now it's 2x plus 1. So instead of just x equaling 7, now we need to make 2x plus 1 equal 7. And we also are going to need to make 2x plus 1 equal negative 7. Does everybody see that? Yes? Maybe? Kind of? Alright, so two equations. So I like to kind of branch off of the absolute values. My first one, I'm going to take the positive. So 2x plus 1 is equal to 7. Gets us our positive distance away from 0. My second equation is going to take us in the negative direction away from 0, which becomes 2x plus 1 equals negative 7. Can we solve those equations? Hopefully. Can anybody do it in their head without doing work? Kevin already did it. Subtracting 1 gets us to 6. Dividing gets us 3. On the other side, subtracting 1 gets you negative 8. Dividing gets you negative 4. Okay. Last year you would have just boxed that and said those are my answers, but we're going to put it into set notation. Always work from smallest to largest, so which one would go first in my list? Yeah, so it would be negative 4, comma 3. Okay, remember, set notation is just a list. You're just listing out the numbers. Okay? So far, so good? Okay. Let's throw in some inequalities with an and. Hold on, that's not what I want to do. Ignore that. Apparently I didn't delete that out. All right, the absolute value of x plus 3. Now we have a plus 5 after it, and that's equal to 12. Before you can split up your absolute value into a positive and a negative equation, you need to get this absolute value by itself. It is incorrect. I'm going to show you the wrong thing to do. Don't put this on your notes. It is incorrect to say x plus 3 plus 5 equals 12, and then x plus 3 plus 5 equals negative 12. Okay, I mean, this will still get you a correct solution, but this won't get you a correct solution. So you'll get points off because you're not going to have the whole entire solution. So before you can do anything, we have to subtract that 5 to the other side. So now we get the absolute value of x plus 3 is equal to 12 minus 5 is, what, 7? So now I want my distance away from 0 to be 7, which means I'm going to have positive 7, I'm going to have negative 7. I no longer just have an x, I have an x plus 3. It's okay. So first equation will be x plus 3 equals 7. Second equation will be x plus 3 equals negative 7. Left side gets me what value? 4. Right side gets me negative 10. What comes first in my set? Negative 10, then 4. That was not a good brace. Okay? So before you can do anything, you have to get the absolute value sign all by itself. If there would have been a, this wouldn't work as nicely, but if there would have been a 3 out in front, when I would have gotten to the second step there after subtracting the 5, what would I have had to have done before getting rid of, or before making my two equations? I would have had to divide by 3. That makes it a little bit ugly because it's 7/3. Then we would do x plus 3 equals 7/3, and then x plus 3 equals negative 7/3. So you have to get that absolute value sign all by itself before you can set up your equations.
Can you divide by 3, so subtract the 5?
Can you divide by 3? You could, but you have to make sure you divide this by 3, the 5 by 3, and the 12 by 3. So you'll still have 5/3 and get a funky fraction. Okay? Yeah, so you can do that as long as you just, get rid of it. Okay, so another absolute value equation that you might possibly see is when an absolute value equals another absolute value. Now this is where it gets really complicated. So, if I have an absolute value with an x term inside of it here, if I had an absolute value with not an x term, if it was just 3, well, the absolute value of 3 is 3, so that would just turn into a nice thing. But if you have an x term inside this absolute value, you still have to make your two separate equations. So your positive is just getting rid of your absolute value signs. So I want the distance that this is away from 0 to be in the positive direction. So just get rid of your absolute value signs for the first one. But then your second equation, you're going to have to take the negative of everything inside that second set of parentheses. So you'll multiply it by a negative, all those terms, to get your negative direction. Okay? So it's just like we were doing before. You take the positive. It's just now your negative gets a little bit more complicated because you have two terms instead of just one term. Like the other ones, we had 7 on the right side, so we just made it -7. Now we're going to have something else with it that's going to have to also become a negative. Okay? All right, let's do an example. The absolute value of z plus 6 equals the absolute value of 2z minus 3. So again, the first equation is always the easiest. You just knock out those absolute value signs. So the positive equation would just be z plus 6 equals 2z minus 3. It's the negative one that gets a little bit challenging. So it's going to be z plus 6 equals, what's going to be on the other side? Yes. Can I jump right to that, or do you guys want me to show the distribution? I'll show the distribution if you want it there. You don't have to if you want to jump right to it. So it would be z plus 6 equals negative 2z plus 3. Jenna?
Why wouldn't the first part of that equation be
Good question. I'm glad you asked that. So Jenna's asking, why would we not also change this part to negative? Is that what you're asking? So just keep in mind what we did before when we had the absolute value of x plus 3 equaled 6. I had x plus 3 equals 6. I did not make it negative x minus 3 equals negative 6, right? This stays x plus 3 each time. Now, would it be incorrect? I mean, technically, we could flip-flop this, right? So that this would stay positive and this would go to the negatives, but one of them needs to stay the same. Okay? Thank you for asking that. All right, so hopefully you already have solved these by now. If not, let's do it. I get 6 is equal to z minus 3, so 9 is equal to z on the left. Adding 2z to both sides gets me 3z plus 6 equals 3, not negative 3, 3. Subtracting 6, 3z is equal to negative 3, z is equal to negative 1. What's going to come first in my set? Good, negative 1, and then 9. Okay? So don't forget the negative. We always are going to have a negative equation. And it happens to have more than one term over here, then make both of them negative. All right, let's do the inequalities. Almost there. Oh, hold on, we better do this before we do that. Quickly write this. The absolute value of 5r minus 3 equals negative 4. Sorry, I forgot our special cases. Is there any possible way that I can get anything to be the distance away from 0 to be negative 4? No. It's not going to happen, right? No possible way that I take the absolute value of anything, it's going to come to be a negative. So these should be your favorite problem, because you don't have to do anything. What do you say for your solution? Yeah, just be no solution. So right away, if you see an absolute value equal sign equaling a negative, bam, no solution. Done and done. Okay? All right, let's get to the inequalities now. Oops, come back. That one's too easy. Let's go to a harder one. Okay, so we have the absolute value of k plus 6 minus 3 is less than negative 5. What are we going to do first? Add the 3 over. I like that idea. So then we get the absolute value of k plus 6 is less than negative 8. Now let's think about this. Negative 2. Thank you. Yes, not negative 8. Well, let's still think about this. Is there any way that I'm going to get the distance of something from 0 to be less than negative 2? No, right? So this is going to be a case of no solution. If I were to flip that sign, if our problem would have ended up looking like this, that it's greater than -2, well, what numbers are greater than -2? We get to positive numbers eventually, right? So if it ends up being greater than a negative number, then it is going to be all real numbers. Because it doesn't matter what number I put in here, it's going to be greater than -2. Doesn't matter which one, right? If I put in 0, is the absolute value of 6 greater than -2? Yes. If I plug in -5, I get +1. Is that greater than or equal to -2? Even if I put in, let's say, -10, -10 plus 6 is -4. The absolute value of -4 is 4. Is 4 greater than -2? Yes. So if you have an inequality that is greater than -2, that's going to be an all real numbers situation. Yes?
How would that be all real numbers, though?
Because I can put any real number in place of k, and after I take the absolute value of it, it will always be greater than a -2. Because remember, absolute value always ends up being positive. Yes?
Yeah.
So you can pick any number you can think of, and plug it in here, add it to 6, take the absolute value of it, which will turn it into a positive, and it will be greater than -2. Okay? I won't be able to get something to be negative, so that's why this is the no solution. But these will be all real numbers. Okay? Does that help to clarify? All right, so there are special cases there, and hopefully you'll be okay with the other inequalities. Let me just give you another inequality since we have some time. If you had to solve, I'm going to do 48. The absolute value of -3 plus t is greater than 8. Is the absolute value sign already by itself? Yes. If there would have been a 2 out in front here, we would have to have done what first? Divide, but we don't have to do that. Okay, so it's already by itself. So someone give me the positive inequality. Good. -3 plus t is greater than 8. Good. What's the negative going to look like? So the -3 plus t stays the same. Now it's going to be a -8. But you have to remember to do one thing when you go to your negative version when doing an inequality with absolute value. You have to remember to flip the sign. So we have to remember to flip the sign.
But wouldn't that be no solution?
Nope, because we don't have the absolute value anymore.
Oh.
Because we got rid of it. But that's good. You're thinking of it. You're thinking that's good. Once we get rid of the absolute value, then that goes away. Okay? Because remember when we had our graphs of our inequalities, the arrows were going out and to the left. So that's why we need it to go this direction, and we need to have it going that direction. Okay, so on the left side, adding 3 gets us t is greater than 8, 9, 10, and 11. Adding 3 on the right side, -8 plus 3 is -5. Now, if you thought about this in a graph form, sometimes it's easier to see if it's an intersection or a union if we did the graph. Which way is my... Yeah, it's going to be a union. My arrow's going to the left at -5. And my arrow's going to the right at 11. Yes, Maddie?
Do we have to graph these every time?
You don't have to. If the book says it, don't worry about doing it for your homework.
Okay.
But sometimes it helps just mentally to see what's going on. Carly?
Do we have to run
Not for all of them. And if they do, I'll just throw a number line up there so you remember to do it. Okay? So my solution set is what?
-6
to 5 to negative 5, union 11 to infinity. Okay? If my original sign would have started out with a less than, what do you think it would have been? An intersection or a union?
Intersection.
Yeah, it would end up being an intersection. So if we would have flipped the signs, so if my original would have started out as a less than, this would have been a less than. I guess I should do this in a different color so we can see the difference. This would have been a less than, this would have been a less than, this sign would have turned to a greater than, so then this would have been greater than, this would have been less than, then we would have had everything in between, so then it would have just been negative 5, comma 11 with parentheses. Okay? Are we feeling okay? All right. So,